So I'm starting this video on a bit more of a depressed note than usual, and that's because, as you guys would have just seen a few hours ago, my house was broken into. Now fortunately, I did have my security system running, the one that I built myself using Python just last weekend, so I was able to actually get all of the video footage of the person who broke in. Now I will say they were extremely attractive, young, white, male, about 5'10", ripped, super handsome. So if you guys know who that is, please leave a comment down below. I've already reported it to the police and to the insurance, but I wanted to make this video so that you guys don't run into the same problem where you have an extremely good looking robber breaking into your house. So if you guys want to learn how to build a security system in Python, make sure you watch this video. I'm going to go through the architecture, I'm going to talk about the code, and of course I'll leave all of the links in the description so that you guys can avoid this situation, or at least catch someone if they do break into your house just like they broke into mine. Alright guys, so all jokes aside, I want to share with you a really great project that you guys can work on, extend, or even build from scratch, which is a Python security system. The idea here is just to give you a quick overview of how it works, talk about the architecture, and give you a really great project that you can work on and especially add to your resume. This is one I've been wanting to build for a long time but never got around to, so fortunately I had a weekend to spare and I kind of coded this out in a few hours, set all of the different things up, and I want to give you a quick demo of how it works and then talk about the architecture and the layout so you guys can go and build this yourself. I promise it's a great project, looks really good on a resume, especially because it's a real world use case. So in front of me, you can see here that I have my security system admin panel. Now this is just a really simple user interface that shows all of the videos that were recorded by this camera setup. Now I'll dive a bit more into the architecture later, but essentially I have my MacBook just sitting down kind of in my main floor, and I have it hooked up to a webcam that's on a tripod, and that's kind of running most of the software which is recording all of this video. Now this is just running on a local web server on a React server here where I'm able to preview all of the videos, and you can see I can click into like a video like this where I was just testing it out, and we can play the video and you can see me kind of waving to the camera. We can go full screen, exit out of here, go back, and then I have the ability to disarm or arm the camera so I can actually see what's going on. Now additionally, I actually set up notifications on my phone using Twilio, I don't know how you pronounce it, but you'll see I'll put this up on the screen. I have a bunch of text message notifications I get every single time motion is detected on the camera. Now what I did here specifically is I made it so it only detected person motion. That's because I have a cat. My cat runs around like crazy, and I didn't want to get a million text messages when my cat was just running in front of the camera. So I ran a really simple machine learning model in something called OpenCV, which I'm going to talk about in a second, which actually just detected for people in the frame. And as soon as someone left the frame for a certain amount of time, it kind of captured that recording, uploaded that recording, and then allowed me to view that from this panel here. Now I've set up a few other things where I can kind of go through some different date ranges. You can see here when I was just testing this out, I have some videos, and that's kind of it in terms of the interface and the demo for this system. I know it seems pretty simple, but this is really cool. You can extend this and you can add different types of motion. You can have other kinds of events, emails, multiple cameras at the same time. Anyways, let me get into the architecture here and talk to you a bit more about how this works. So the way I actually started this project was just by creating a few design documents and kind of planning out what I wanted to build. Whenever you're working on a larger project like this, it's usually worth the upfront investment, maybe an hour, 2 hours, to actually create a few basic design documents so you know what you're going to be building, the different components you're going to have, and how they're going to interact with each other. So you can see here that I made a basic system diagram, I made a sequence diagram, and I even did a really quick user interface wireframe. Now, a lot of you guys ask me how I build these documents, and the tool that I use is actually called Miro. Now, Miro is the sponsor of this video, but it's completely free to use, and it's a digital workspace where you can actually collaboratively work on different documentation for your various projects. I use them personally just for system design, sequence diagrams, all the stuff I just showed you, but you can use it for practically anything, and you can kind of connect with teammates. So I've actually used this with my Discord team a few times when we were planning out some different projects we were going to work on. Anyways, you guys can check them out from the link in the description. But for now, let me just show you the kind of diagrams I created using that tool for this project. So you can see here that I wanted to just start by figuring out what different components we were going to have here. So what I wanted to have originally was a Raspberry Pi or some kind of remote computer that wasn't my home machine here, my big desktop. I ended up just using my Mac because it was a little bit easier, but originally it was going to be a Raspberry Pi. I wanted to have a camera on that Raspberry Pi, so just a webcam, and then some person detection, model, right? So some machine learning model that would actually detect if a person was running. Now for this, I wanted to use Python, so I kind of just put that in a little box. Now that was going to be connected to a Flask API. And this Flask API, I wanted to run on the actual kind of physical hardware device. So whatever was running the camera, which in this case is kind of the Raspberry Pi. Anyways, the Flask API was going to be the main interface between the user interface, notifications, the cloud storage, and all of that kind of stuff. So I kind of put that in the middle here. And then you can see that I have a Google Cloud Object Storage. Now, this is where I wanted to actually store all of my videos. So I ended up creating a bucket in Google Cloud, and that's where I dumped all of the different video files. So essentially, the Flask API is responsible for arming and disarming the camera, saving and retrieving all of the videos, and getting information about the video metadata, which I'll show you in the sequence diagram in just a second. Beyond there, we have a user interface. I wanted to build this in React with JavaScript, so I kind of put those two little icons there, and this would connect to the Flask API, and then that's how we would get the different URLs of the videos and control the camera, right? So arming it, disarming it, all of that's happening through this API. Lastly, I wanted to have a notification system, so whenever someone went in front of the camera, it would send me a text message. So to do that, I used Twilio, Twilio, I think that's how you say it, and that's kind of connected to the API. So whenever motion is detected from the camera, goes to the API, stores it in Google Cloud Storage, notifies myself, and then updates the UI and kind of shows the new video that was there. So that's the whole system. You can see that we have a few different components going on, and it's a good idea, even if it looks kind of rough and sketchy like mine does, to just plan that out and see how those components are going to interact with each other. So beyond that, I have a sequence diagram. Now I'll dive into the code and show this to you guys in a second, but you can see this is actually how all of the different systems are going to interact with each other in a specific order. If you did any type of computer science degree, you've probably seen a diagram like this before, but it's really good for visualizing kind of what's going on and what is controlling what, right? So in this case, we have UI, our user interface. So from the user interface, we have really three main things we can do. We can arm the camera, disarm the camera, view the video, and that's pretty much it, right? So from the UI, we send the armed command. Now we send that to the API, and what the API does is then go and control the camera. So whatever software is running the camera. It starts the camera starts running, and then at some point, a person is detected in the camera frame. There's some machine learning model going on there. As soon as the person motion is detected, it notifies the API. The API then goes and saves the video in the Google Cloud Storage, and then that storage is going to return the video metadata. Now from there, we could use that data if we wanted to, but this kind of little dotted line is just indicating, hey, something is coming back from the request or the call that you made. So next, once we get the video metadata or the URL, then what we do is we send a notification, so using the notification service, which is Twilio, and then that returns to us that the notification is sent. So at that point, I could have added another little box saying user receives notification, but you get the idea. Okay, so that kind of just goes infinitely, right? That will continue to happen every time a new person is detected. From there, we have the disarm command. Now, once the disarm command is ran, that means we're going to stop running the camera or release that resource, and then that's pretty much it for the camera until we decide to arm it again. Lastly, from the UI, we can view the video. When we want to view the video, we go to the API. The API then retrieves any of the videos or video that we want to view, returns that data, and then returns that back to the user interface. So hopefully you can see how this would be a helpful type of diagram, but this is what I started with, so I knew kind of the flow of my different commands and how the systems would interact with each other. All right, so lastly, after that, I did the user interface wireframe. Now I just spun this up so I had some idea what I wanted to actually create. I didn't do the exact replica of this on the actual user interface that I built, but you can see that I wanted to have some kind of title, the ability to arm and disarm, and then just show the different logs with kind of a little thumbnail image, and the ability to go between the different dates or the different pages of videos. And then I wanted one other page here, just as like a details page to view the information about one individual video. So there you go. That is my design documentation. Now I'm going to get into the actual code here, but I just want to show you kind of how I built this in Miro, because a lot of you guys ask about this. Again, it's completely free and it's super easy to kind of create the different components. All right, so I just signed into my Miro account here, and you can see if I go to something like my sequence diagram here, I will kind of pop this up, which I actually just exported as a PDF. Now from here, you can just grab the different components, right? I could copy and paste them and kind of move them around, or I can just use some of the different components from their library. So what I actually did for this is I went over to shapes. I went to all shapes, and then you see that we have a few different options, right? So you have basic shapes, flowchart, callouts. You can also go to more shapes, and then you can select all the different ones you want. Now, for most of you, you're probably going to be interested in the UML shapes, which are some of the ones that I used, or things like data flow, but you can see there's stuff related to Azure, Cisco. So this is kind of made in a way such that if you're a developer, you're going to have access to a lot of pre-built components here to make it a lot easier to diagram your stuff out. So I don't think I really need to show you much more than that, but the point is that it's super easy to just go in here, kind of drag all of the different components that you need. You can just make arrows and move them around, and I found it pretty simple to set up the diagrams, hence why I used this tool. All right, so now let's spend a few minutes diving into the code. If you guys want, this will be available in the link in the description from GitHub. Now, there's a few things that you need to set up here if you want this to work, which I'll explain here. But if you just want the code and you want to search through yourself, then just go to the link in the description. You'll find the GitHub page. So first of all, we have a React front end. I'm not going to really run through that front end there. All I'll mention is that I just have a few different API calls that are happening from the front end. So you can see I've just linked up the IP address of my kind of local server, which is just running on my local network. So this is the local IP address of my Mac, which is running the camera and the API. You can see that I start by just getting the status of the camera, so if it's armed or not. And then I have this kind of little fetch command here, which will get me the videos within a certain day. So from one day to another day, that's how I set it up. And then lastly, I just have two little commands here, two little endpoints, disarm and arm, to arm and disarm the camera. And that's all that's really happening from the front end, right? Interacting with that backend API. So that's it for the front end. In terms of the back end here, I have my Flask server, super straightforward. You can see I have my arm endpoint, disarm, get armed, motion detected, and then get logs. Now, motion detected is what's going to be called from the actual camera thread, and I'll talk about the threads in 1 second, which will then send the notification to my phone saying, hey, someone was detected at the front door, or whatever the camera is that you want to name this. Okay, and then get logs, that's just going to get the, kind of different logs or videos, from the Google Cloud storage. Now, in order to separate things out here, I created a notification script. So this is just simply sending a notification to my text message. I've got all this stuff set up in environment variables to my text message, to my phone number, sorry. I've got storage here. What storage is doing is uploading to the Google Cloud storage, and then it is getting all of the videos from the cloud storage within a certain date range. So that's something you can do. And then what I did here is I just set up something so that I actually encode the video before I upload it to Google Cloud using this FFmpeg or whatever you call that, simply so that I have the video in a format that the web browser can understand, because by default, the OpenCV recording format, which is what I'm using for the camera, doesn't actually show up in a preview. So I was getting some issues with that. So I just had to actually use this software to encode or kind of transcode the video, remove the old video, get the new transcoded video, and then upload that to Google Cloud. Not sure if that makes sense to you or not, but after all of this is done, then what I do is I send a request to the API that just says, hey, this is finished. This is the URL of the video. And the reason I need to do it that way is that I run all of this stuff in a separate thread, and it needs to be in a separate thread because while this is running and uploading the video to Google Cloud, I want my camera to still be working properly and be able to record video and detect people while I'm uploading potentially a very long video. So what kind of happens is from the camera, when motion is detected, it then goes and does all of this kind of storage stuff here where it's handling the detection. It then sends the request when it's finished back to the API and says, hey, we've just finished doing all of that. And then it sends the notification and goes from there. Not sure if that makes sense or not, but that's kind of what's going on here inside of storage. Lastly, we have camera. Now, this is where most of the complicated code is. What I'm doing is I'm reading in a pre-trained model, which simply detects a person. I am then getting access to the camera. So whatever the default camera device is, in this case, it would just be using your webcam. You could also set it up to use a external camera if you had that set up. Now, inside of here, we just have two methods, arm and disarm, which is what's being called by the API. And again, everything that you're running here needs to be inside of a separate thread so that your API can be handling any type of request that's received while the camera is running in a completely separate thread. And that's why we have that kind of communication with the API from the camera thread so that we can have data transmitting between the different threads without any complicated locks, which I didn't want to set up. This is a little bit advanced. If you're a complete beginner, this might not make a ton of sense, but what I'm doing is running every individual operation that is blocking in a separate thread so that we don't have the two threads conflicting with each other. And while we're, say, uploading a video to Google, we can't be recording someone on the camera. Or while we are recording, we can't be receiving a new request from our API. So we need to make sure we have these in separate threads. So as soon as we arm the camera, assuming it's not already armed, then we're going to create a new thread and run the camera thread. Otherwise, we just dispose of the camera thread, which happens right here inside of disarm. So inside of run, we have a few basic variables, right? If we've detected a person, non-detected counter. This is just so that we will keep recording even if the person steps in and out of the frame for a few seconds. Then we get access to the camera, okay? And we kind of go through here and we get access to the current frame from the camera. We then use that frame to detect if a person is there. So this is kind of detecting all of the people that are inside of the frame and then drawing a box around them. We're then saying if we've detected a person, what we're going to do is start recording a video. So we're going to actually take whatever this current frame is and we're going to save that into a video file. And then as soon as we're no longer detecting a person, what we're going to do is take that video and we're going to upload that to Google Cloud, which is what happens here in the handle detection. That's pretty much it. But as soon as someone is detected, we start saving a video locally on the computer. Then we upload that video to Google Cloud, delete it from the computer, and just continue the rest of the process. So that is it for the backend. I was going to say, if you do want to set this up, then you need to create a credentials.json file with your Google Cloud project where you have a Google storage bucket created. And you also need to go into this env file, rename it to .env, and need to put in all of your Twilio information to be able to send the notification. That's about it. Everything else is in the README file. And I think with that said, I'm going to wrap up the video here. The point of this video was just to demonstrate a cool project that you guys can work on, extend, and build. This is something I had a lot of fun making. I think it's really cool. It's actually useful if I wanted to leave this running 24/7. And I think it looks really great on a resume because it is a more unique project, something that not everyone's building and that you legitimately could have a real use case for. For example, I was going to set this up near my cat feeder and I was going to record every time my cat went and got food and kind of track its eating schedule. So that would have been another cool variation of this, but I didn't want to wait the days and days to kind of accumulate all of that information. Anyways, if you guys enjoyed, make sure to leave a like, subscribe to the channel, and I will see you in another one. Remember to check out Miro, the sponsor of this video, if you want to create those design documents just like I did for this project.